All right, we're going to start off on number 2 here. So it says express the set of real numbers between but not including 2 and 9. So I want to be in between 2 and 9. And then it says not including, so I would think that both of these should not have a line underneath. So I'm going to take off that one and that one and that one. And then so we're down to the last 2 here. And what I always say is kind of just think about it as if the x wasn't there. What would the inequalities be opening up to? So I would say they would clearly be opening up to 9 and pointing at 2. So that's how I would tell the difference between those. All right, next up here, they want to write these as inequalities. So when it says x is positive, you kind of need some interpretation here, but we know that if it's positive, it would have to be greater than 0. All the numbers that are greater than 0 are the positive ones. And then less than 5, that one, not really any interpretation needed. That would just be like that. And then greater than or equal to pi would be greater than or equal to pi. That's a direct translation as well. Part D there, I'll let you guys try. And then part E, it says the distance here. So distance is always going to be subtraction. And so we're going to subtract p and 9. So it's not going to be these two. And then well, that's in an absolute value, because I don't know if p is bigger or 9 is bigger. So if I have it inside of an absolute value, it makes it irrelevant, since distance is always positive. So we find it by subtraction, but the answer is always positive. And then it says at most 7. So at most, that actually means less than or equal to. All right, next up here, it says this wants us to express this in terms of inequalities. So just kind of remember here our faces of inequality. So these symbols all go together. And then these symbols all go together. And so when I have this one, it means that I should have the x in the middle, and then the 7 and the 9. This one should be an or equals to, whereas this one is not. And so then I would say the answer is A. So then we would do this on the number line from 7 to 9. There should be a closed circle here and an open circle there connected. All right, this one here, I might do the graph first. So when it says x is less than or equal to 5, that would be a closed dot going this way. So then for the interval notation, I need to think about where this starts and where it stops. It actually doesn't start at 5. It actually stops at 5 if you kind of think about us reading it left to right. So where does it start? Well, it actually starts at negative infinity. So it's going to be from negative infinity to 5. Notice this one's a bracket because of the closed dot, but infinity and negative infinity are always parentheses. So just keep that in mind, okay? Always parentheses. All right, next up here for this one, we're going to express it in interval notation. So this one has a clear start and stop, so it's not too hard. And then the closed circle is a bracket, and the open circle is a parentheses. All right, these next two, the trick we learned is that we can always write this without the absolute value if we just write it as big minus small. Because if we do big minus small, we know that answer is going to come out positive. So for this one, I know that 8 is bigger than rad 8, so I'm just going to flip that around there. And then I know that the answer is going to be positive, so I do not need the absolute value. Now, on the other hand, we have 17 minus pi here. That answer, I actually know that 17 is bigger than pi, so that one I'm not going to flip it around. I'm just going to write it without the absolute value since I know that answer is positive. All right, these next ones I need to just do it step by step. So I need to take care of these inside absolute values first. So that's going to turn that into 8 and that into 1. But the negative in between them is going to stay put because I haven't really dealt with that yet. But I took care of the inside absolute values. So now I'm going to do 8 minus 7. I don't change that minus to a plus. I have to actually do the subtraction. And then the absolute value of 7 is obviously 7. Next up here, I need to take care of that absolute value on bottom first. So that'll be negative 13 over a regular 13. And so that's going to come out to negative 1. All right, next group here, we have some practice with our properties of exponents. So if we have 2 bases multiplying, that is addition. And then for this one, we're going to send this third power in there, and it's going to multiply by the exponent. So I'm just going to remind myself that 2's exponent is actually 1. So it's going to be 2 to the third times y to the 6th. And then I would just call that 8y to the 6th. For these two, I would add the exponents, and that'll just be y to the 4th. Or if you wanted to look at it like we drop that y to the 2nd to the bottom, and then we battle them out, we would get y to the 4th either way we look at that. All right, next up here, I'm first going to send in this exponent and multiply everything in there. So that's going to be b to the 14th over b to the 7th, and then I'll do the same thing here. So that'll be a to the 12th, b to the 8th, and then over c to the 12th. So now I'll either battle, oh, that's the a up there, okay. So now I'll either battle or combine forces. So the a's are going to combine forces since they're on the same level. They're both up top. So that'll be the 26th power. The b's are actually going to battle. So we have 7 down here and 8 up there. So the top is going to win that by 1. Now when we have the first power, I wouldn't actually write it there. And then on bottom here, I have c to the 12th. It really didn't have anybody to battle or combine with, so I'm going to leave it like that. Next one here, kind of same idea. I'm going to, since the parentheses are just up top, I'm going to send that up top. So we get u to the negative 2, v to the 4th. And then on bottom, I have u to the 9th and v to the negative 6th. Next thing I like to do is move all my negative exponents. So I'm going to move the v to the 6th to the top and the u squared to the bottom. And then I have u to the 9th as it's going to stay put on bottom and v to the 4th up top. So actually no battling here. I'm just going to combine the v's up top and give me v to the 10th, and combine the u's on bottom and give me u to the 11th. All right, next up here, I'm going to go ahead and do b. So for this one, that negative 27 is not in parentheses. So really what I need to do here is the cube root of 27 and then make that negative. Because on this one, the denominator is the root and the numerator is the power. So you can think of it as a 1 out there, although that's not really necessary. So the cube root of 27 is 3. And so this one would be negative 3. Part C is a little bit different here. So this one has a negative exponent. So negative exponents go to the bottom. So that's going to be 1 over 49 to the 1/2. And so that's really saying 1 over the square root of 49. And so it'll be 1 over 7. Next set right here. So for these ones, I would simplify these first before I start switching things to roots. So for these ones, we're going to add them together. So it would be 5 to the 14 over 7 power, and so I added the exponents since they already had a common denominator. That was pretty easy. So it's really saying 5 squared, and so I would say that's 25. This one here, I would battle those out, so that means subtracting them. So 5 over 3 minus 2 over 3 is 3 over 3, so that's 1. So it's 1 over 3 to the first. I knew that ended up on bottom because that was the bigger exponent, and so I would just list that as 1/3. Number 8, to make this problem a lot easier, what I would do is I would think of this as 8 to the power of negative 10 over 5. Kind of going the other direction here, we know that the fifth root is can turn into the denominator on a fractional exponent. And this makes things a lot easier because now we can just see this as 8 to the negative 2nd power, and then flip it down to the bottom and call that actually 1 over 64. All right, next up on number 19a, for this one, I would just multiply the big, oh no, we can't do that yet. We have to send this in here. So this is going to become 16 to the 1/2 times b to the 1/2 times 8 times b to the 1/4. I would go ahead and simplify this 16 to the 1/2 as the square root of 16, being 4 there. So I'm going to call this 4b to the 1/2. And you know what I'm going to do here? I'm going to think ahead. And I know I need to add these guys together, so I'm going to think about a common denominator. So I'm going to call this the 2/4 power now. And then we'll make this times 8b to the 1/4. So I'll multiply the big numbers together first, the regular coefficients. So that'll be 32b to the, and now I can add those together as 3/4. All right, next up here, I'll go ahead and do, let's see. I'll do part B here. So for this one, I would send in this 3 over 2 power, so that becomes 9 to the 3 over 2, s to the 3 over 2, t to the 3 over 2. And then this down here becomes 27 to the 2/3, s. And then that one I'm going to have to multiply 2 over 3 times 3 over 1. So that's 2, so s squared. And then t to the power of negative 8 over 3. And then this one as well, I'm going to have to multiply everything by negative 1. So that's 3 to the negative 1, s to the 2nd, and then 4 to the negative 1, t to the negative 1/3 on bottom. All right, what would I do next? Next up, I would take care of this one. So that is the square root of 9 to the third. So that's 3 to the third, which is 27. And then this one down here is the cube root of 27 to the power of 2. So that's 3 squared, and that is 9. So those did end up flipping, not because of negative exponents, but because of the fractional exponents. I would then move all my negative exponents here. So s to the 3 over 2 going to stay on top, s squared on bottom. T to the 8 thirds going to go up top. T to the 3 over 2 going to go up top as well. And then we'll do this one as well. So that'll be 4 up top, 3 on bottom, s squared, and then t to the 1/3 will move up top. Okay, you know what? I see a little shortcut here. We have this s squared and we see this s squared. Those can actually cancel out. So that helps me with my s's here. So I'm going to end up with s to the 3 over 2 on top. All my t's here need to add. I would add these two together first since they already have common denominator. So that's going to mean I have t to the 3 over 2 times t to the power of 9 over 3, which is just 3. So now I'm going to add those together with common denominator. I'm going to make this 6 over 2. And so that'll give me t to the 9 over 2 power. Now for the numbers, I actually see that these two are going to multiply here to give me 27 on bottom, which will cancel out with the 27 on top. So I'm just left with 4 there. So this would be my final answer. All right, next up here, it says put each fractional expression in standard form by rationalizing the denominator. What I would always do here is I would always think of these as fractional exponents. So I'm going to do s to the 1/2 on top, and then 6t to the 1/2 on bottom. And then I'm going to multiply this by 6t to the 1/2, which would make that just a regular 6t, kind of make it the first power. But if I do that on the bottom, I'd have to do it to the top as well. And so that would just mean that 6st would all be to the power of 1/2. So with part B here, I would think of this as the b to the 2 over 6 power, which really I would think of it as b to the 1/3 power. And then I would multiply that by b to the 2/3 power. And once again, my goal there is to make that denominator be whatever to the first power. And then that would mean my top is a times b to the 2/3 power.